So my name is Alexandros Papadopoulos. I'm Greek, for those who didn't understand. Call me Alex, because probably 99% of people cannot pronounce my name. So just to know my audience, how many of you are actually DevOps engineers? Wow. Okay. How many of you maintain a Kubernetes cluster? Wow. And how many of you actually set up a Kubernetes cluster from scratch? Well, that's a lot. Okay. Cool. So, tell you the truth, guys, I didn't know exactly what to prepare for this presentation. I didn't know the level, but it seems we're kind of like 60-40 here. So I'm not going to show you any crazy graphs. I'm not going to show you anything amazing. If you were expecting to see some like scenes with bubbles and some graphs of showing you, oh, look at this, like, oh, how amazing Kubernetes is, no. This is going to be a real talk about what is Kubernetes, what's the positives and what are the negatives of Kubernetes, what happens when we get started with Kubernetes, and what will happen, actually what's going to happen to your bill in the first 6 months. Last, we're going to talk about the alternatives. So, the agenda. So let's get started. So understanding the Kubernetes landscape. I'm going to have a back dive in the 2000s just to see what happened back then and why. So Java and PHP used to rule the world. They still do, but yeah. Everyone was creating monolithic applications because, you know, microservices were not really a thing. You would just create this huge thing. You would not even test it. You would throw in a server, which you rented from someone else. You really, actually, you didn't even have a Focus one, then we had Nomad from HashiCorp, never lifted off. Of course, it's actually pretty good. And then we had Pokemon Go. And that was the only reason why Kubernetes won. Because Google Cloud came out, Pokemon Go got released, and it didn't fail. It handled 10 times the traffic, it scaled up to 100 times over, and yeah, that war was won. Then we throw our 3 hours away, and even AWS, who didn't really want to actually have Kubernetes on their platform, introduced it in their platform. By the way, the worst one ever. So, 2020s. Every person who used to write a dynamic language before suddenly became interested in Rust. I still cannot figure why. PHP still rules the world. 75% of the internet is PHP, is literally some kind of variation of PHP. Jenkins just doesn't want to die, just breaks a lot, but doesn't want to die. Yeah, we treat monoliths now as microservices because, why the hell not? We can put it in Kubernetes, it's going to work. Never going to die? Sure. And AWS slowly gets replaced by Azure. Testing is greatly improving. I'll say that with a grain of salt still. And we use Kubernetes for everything. Doesn't really matter. You want to create services, you install, you want to work with serverless, you install FAS on Kubernetes. Wow, I have serverless. You want to create tasks, cron jobs, you just create tasks on Kubernetes. There's no problem, right? You can just do whatever you want to, right? Just throw everything in. And that's the bad idea out there. So, the infrastructure today looks like just Kubernetes. A small company has almost 10 clusters, just because namespaces are not good enough. Yeah. Companies started leaving the cloud. I do not know if you have seen the latest David Heinemeier Hansen release. And CNCF grew quite a lot. So we can customize our Kubernetes as we want to do it. Doesn't really matter. Whatever you want to put in it, you can put in it. But what do you put in it? Because there are a hell lot of choices. So just to give you an example on that. Oops. Let's see. Can I click this? I can't. It's another page, but it's okay. So this is more or less what we currently have. Imagine that we started and then it was like a couple of services here, maybe something extra. And then almost 10 years later, you can just pick your poison. This is non-stop. And it still goes on. So for everything we want to do, there are already at least 10 solutions out there. Now, the question still comes, how do we customize it? How do we use it? Do we want to use it? So, yeah. And now we enter the benefits of Kubernetes. So, by my personal opinion, those are actually 3. Scalability, resilience, and modularity. We all know that scalability does. We can scale, right? Anyone can explain to me what scalability is, what's vertical and horizontal scalability is? Okay. I'll talk about it later. I just want to know if you guys know. So in the scalability part, we have the load balancer, resource efficiency, horizontal and vertical scaling. Load balancing, I'm guessing we all know what it is. Have multiple services, depending on some weights, we can actually say which service should be hit first. Resource efficiency is a tricky one. It's actually, so all of you guys who work with a Kubernetes YAML is just how much juice are you going to give to this thing to run? And horizontal and vertical scaling is, are we going to scale the container up, or are we just going to start another container? Right. Resilience. We have self-healing. Rolling updates. Rollbacks. The security of what we ever want to introduce inside the framework. We can also even throw Palo Alto in there. Doesn't really matter. You want to do packet sniffing, just do it inside your cluster. And monitoring. Again, we have a ton of stuff. And the last part is ecosystem, the extensibility that we get. So CNCF, as I showed you before, is huge. We have crew plugins now, so you can install whatever plugin you want directly inside your Kubernetes and just have fun, right? Then plus we have Lens and K8s, which great tools in actually to modify your cluster on the go, or if you want to make some quick change, as long as you persist it afterwards. Cool. So here comes the interesting part. Are you guys up for a talk, or should I just continue along? Okay, cool. So the complexity of Kubernetes. Anyone has an idea why Kubernetes is complex? Abstraction. So what would happen? What would be the difference if I actually had, like, I don't know, an EC2 service versus a Kubernetes deployment? No. Okay.
More knobs.
Sorry?
More knobs to turn.
Yeah, true. True. More YAML files, right? Because it depends. What do I need? Do I need a persistent volume? Do I need a persistent volume claim? Do I need a deployment? Do I need a service? There are a lot of stuff that you need to configure. Something that, for example, if you go on AWS, where I mostly work, is literally I throw it on an EC2 service. I just redirect my Route 53 domain just to that service. It's done. It's not rocket science.
You can also say that Kubernetes is not a real managed service even. You can buy it, but if you take like a sidekick service, that's managed. You just put your Docker image and it's running. You don't have to do anything else.
Correct.
Like Kubernetes, it's like there are so many switches you can turn, and you don't. If I put over here, breaks this switch, and
correct.
So you have to have your secret manual.
Yeah, and that's why we discovered Helm, right? Everything has to be templated, and everything has to be
secret Helm.
True. So we have a complexity resource overhead. So imagine if you just want to throw up a Node.js application out there, like an Express, right? Application. Let's say it can handle 5,000 requests per second. And I want to just have one instance of that inside the Kubernetes cluster. Like, there is no reasonable argument why you should do that. Even if you scale it up to, I don't know, 10 times, do you actually have the user base for 40,000 requests? So the resource overhead is, we literally sometimes have nothing to put inside the cluster, but we just put it in there. But then again, we kind of have to write the two masters. Then we have to have our service discovery somewhere. We have to have some other stuff running around. Like we have to have Prometheus and let's say Grafana set up there for monitoring. And then again, like in the end, you're just running too much stuff without there being need for it. You can just run a Lambda service. So yeah, monitoring and logging, that's another monster. All the clouds out there are going to try to tell you that they know how to do better monitoring and logging than any other tool, while they are actually using every other tool out there. Upgrades and compatibility, that's a pain. I do not know if any of you guys did a migration from 123 to 125. No? Yeah, that was beautiful. How many plugins should fail? Okay, we need to rewrite all our YAML files because like the version changed, because we don't support the beta 1 version, we support only version 1 now. It's a pain. So it needs constant maintenance.
Just spin up a new cluster.
True.
That's what we put as a procedure. Just spin up a new one, move everything over.
Oh, it depends on what happens if your services are not designed for that.
Yeah, but then.
Yeah, you at least avoid that part. Vendor locking concerns. Every cloud out there will try to vendor lock you. Either that's the most usual part is the monitoring. Right, I'll give you an example of AWS. Everything goes to CloudWatch, but I want to get out of CloudWatch. Oh, but you need to go inside your cluster, you need to set up Prometheus and Grafana, and then you need to remove all the rows that are associated with the sending the data. I was like, okay, why? No one except actually Google can give you a bare naked cluster.
You can actually use the Prometheus managed service on AWS and send your logs to that.
I like the managed part. So you have storage orchestration, as I said before, like, okay, I want to clip something on, right? Oh, I need to make a private volume claim, I need to create the volume, I need to, like, that's what that's gonna be. EBS, oh, yeah, but I need that to be shared with, I don't know, 15 other instances, so let's make it NFS, and it just goes on and on and on. It's totally a problem, because let's admit it. Kubernetes was designed to be stateless. There is not a single cluster out there right now that actually runs stateless. Yeah, over provisioning. Many times we would have like to say like, oh, you know, let's just make sure that we can reach them, I don't know, 100,000 requests. Then you receive a call like, hey guys, but we have 10 customers. Yeah, but let's just do it. And then something gets stuck in your code and suddenly you will just explode. And it just keeps consuming and consuming and consuming and spawning other stuff and spawning new nodes and spawning new pods, and then you see your bill at the end of the month. You're like, ooh, something happened. Security challenges, you need to scan everything, right? From your network to your Docker files to your code, anything before it goes in there should be scanned. That's how it should be done. Yeah, I don't see it. I can tell you, like, I'm a consultant, so most of my customers are, oh, we're gonna scan this and we're just gonna put it in our own registry, Docker registry. And then you see what they do is literally, oh, yeah, let's go to Docker Hub, copy it on my computer, just push it to that registry. But Docker Hub scanned it? No, not really. So service mesh and complexity, any of you work with service meshes? One? Wow. Oh, I'm sorry for you. Okay, so yeah, I'm not even gonna dive into that one. That's even a greater hassle with networking. But yeah, let's say that now that we're scaling, the common scalability types are cluster autoscaler, horizontal pod autoscaler, and vertical. Anyone knows what's a cluster autoscaler? Please. Oh, please. No, you already answered twice.
Basically, it's spinning up new nodes.
Correct. Correct. Horizontal and vertical pod, we answered that one before. Okay, when is scalability crucial? I'm not asking guys, it's listed there, just like for you to see. Variable workloads, cost efficiency, high availability, predictable performance, and resource efficiency. So, okay, now the question begins. What's variable workload?
Have spikes in traffic or different computation formats.
It's when we want to increase or decrease the scale of either our pods or our nodes, depending on the traffic we get. Cost efficiency. How can we actually control that? Each time you're creating a pod or a node, not a node, actually a pod, you can actually define in size how many resources do you need. So if you're running before Kubernetes 1.23, there were these cases where if you actually just said that I want the minimum, I don't know, let's say 1 core and half a gig RAM, and you never specified the maximum resource limit, it would just take more memory, but then if I need to spawn more instances, more pods, it would just eat up that memory and crash the pods. So now it's kind of like it gives you a warning. It's like, ooh, you didn't define the maximum. You probably should want to do that. That also helps you with your cost efficiency, because then if you actually tested your application correctly, you actually know how many resources the application is going to consume. It's not going to be like, oh, it works, it's okay. I didn't run a single test on that. I do not know what's the limit of my application, but I know that it works. I can just put it in there. That's also part of the predictable performance. It's like, how much do we actually need? Do we need it? Because I can go and give, like, as I said, to a minor service, my automatic dog feeder machine that has an API apparently, I can just throw a service communicating with that, and then, yeah, what should I expect from it? Anyway, resource efficiency also we covered. High availability, I think, as we said before, you all know. Let's talk about cost. So there are three types of cost. There's the upfront investment that you do in Kubernetes, and that's like probably you care more about that one as a manager. An ongoing operation cost, and future return on investment. Can anyone tell me what's the upfront investment that you do in Kubernetes?
Instance reservations or anything like that.
Yeah. So it's part of it. Let's say that it's the training and the skill which is required actually for you to learn Kubernetes. It's not an easy journey. You will hit your head, you will make mistakes, you will deploy something that shouldn't be deployed, you will take down something that shouldn't be taken down. And you also are gonna probably invest quite a lot of money in tutorials, not you as you, but your company you're working for. Who's gonna invest money in tutorials? It's gonna invest money in some kind of tutorship that we're gonna come and show us how Kubernetes work. And of course, that never works, and then you have to put more money in there. But let's be honest, the only way that we humans learn is by failure. So we fail once, we see what's wrong, okay, let's try to redeploy it. Okay, something else went wrong, okay, at some point it happens. Then we have the infrastructure costs. So when you first start and say, okay, I'm gonna put my application there on the cloud, you literally get this fun and happy hour when you actually go and say, what can I throw in there? What can I change? You start playing around to find the best environment that you can for your application, if you want to do that. If you have a managed K8s, for example, yeah, good luck. But that all is cost, because you're deploying, you're stopping, you're using network. And usually the first 2 to 3 months, you're gonna pay triple the money that you usually would pay for a hosted Kubernetes. So tooling and software costs, they're always there. They're always this beautiful open source services that always have a paid tier. Use us, and then, if you want this extra feature, just pay for it. And that's how it usually goes. So that's why extra hidden cost in there. Yeah, and the last one is the development and integration efforts. So that is actually the fun part, because that's not pure DevOps part, but you will have to talk with your team and see, like, okay, does it make sense for me to have it like this? Should we, now that we're going to Kubernetes, we need to restructure this part, or this part, or this part. And this is also one of the biggest pains out there. Anyone been in that kind of scenario?
But don't you have that anyway? It doesn't matter if it's a Kubernetes journey or if it's a hosted Docker service or anyway. So that's like, are you doing lift and shift, or are you doing refactoring, or breaking down your monolith? So I think that's not related to Kubernetes. That's just going to
No,
the
that's always there. That's always
that's
there.
just going to the cloud.
Yeah, but it is still a cost at the moment that you are going to Kubernetes. That's the point. So the idea is that, again, you will have to modify it one way or another. Now, if you run, like I have a scenario for you which I don't modify anything, right? I use DHH's approach, and I just write Ruby on Rails, and I can deploy it on a single machine. So, yeah, it doesn't make sense. You will have to change something. You will have to tweak something. And definitely either it's cloud or Kubernetes. You're gonna have to tweak some more if you go first to cloud and then to Kubernetes. But true enough. So ongoing operation costs. Those are the usual infrastructure costs. Maintenance and updates, because you will have to maintain it. You will have to hit your heads on a couple of walls just to make sure that version 123 goes to 125. And I have infrastructure cost-wise.
Because it's expensive.
Yes.
It's expensive. Monitoring and logging, that's an extra cost. Scaling resources, that's an extra cost. Support and training, that's an extra cost.
Are you saying that this is Kubernetes specific, or is this just the general price of moving to the cloud?
No, I'm saying that this is more or less Kubernetes also specific. It applies for the cloud, but it also applies for Kubernetes.
How is it Kubernetes specific?
Because how many requests have you made as to AWS, for example, for a Kubernetes program?
No, but everything costs money in AWS, right?
Yeah.
If I want to make the same setup using ECS, I have to pay for all those things as well. I have to rewrite my application to play nice. What's the Kubernetes specific things?
In the support and training.
Yeah, but even for example, cloud formation, right? It's horrible. I would rather do Kubernetes than cloud formation. So training wise, it's
You save in training by moving to Kubernetes.
moving away
But
from
I think what we're saying, this is just, if you go from on-prem to cloud,
Yeah.
it is the same. It doesn't matter, it's not Kubernetes
Mhm.
specific. If you go to Asia, you have the same steps. If you go to AWS, you will have the same, and if you go to Kube,
That's correct.
It's
Yeah.
the same, so it's not
Yeah.
Kubernetes specific.
It's not.
This is
It's not
just
Kubernetes specific. True. True.
doing, and you can also say this is, if you go from one hosted on-prem to go to NLT or COD, these will be the same cost.
I think personally that the startup costs are much higher because while you have your ECS, you can also have somebody who's maybe a little bit less experienced.
Mhm.
They have to play around with one system. They are on Kubernetes, they kind of need to know everything before they can make a change. Or maybe not everything, but the risk of breaking
If-
stuff.
If there is any kind of previous template, it becomes a bit easier. But then again, you don't know what you're changing up until the point that you fail. So definitely yes. Yeah. So the return on investment. So we have improved resource utilization after we actually experimented with it. We found the limits of our containers. We actually deployed it. Cool enough. Now we can actually say, okay, now we at least we know what we're utilizing and we're not going to overutilize. We have an agility and faster deployment, and that's mostly because we have already templated everything. And now we know which service uses which template, and then we just okay, yeah, Helm deploy. Thank you. Operational efficiency, yeah. We don't really have uneducated people anymore. So they know, they have experienced some downtime, they have experienced some mistakes, and now they know what they're doing. Scalability and flexibility. We scale and we are flexible, and we know that on Black Friday everything is going to be running. High availability and reliability hits exactly the same point, and consistent development and deployment, that's actually a funny part, because that almost never happens. But yeah, we're just going to leave it there. Okay, so let's talk about some alternatives. We saw Docker Compose coming and going, Docker Swarm, Mesos, Nomad, ECS, Cloud Run. The scalability and flexibility, I do not know how it appeared there, but it's okay. I'll remove it later. And that should be it. Anyone? Okay, let's say I give you a use case. So you have a small startup. You are now developing a product. What do you use to deploy? Where do you deploy? Fly.io?
Asia using managed services.
Okay, that's also something. I would still agree with Fly.io because it's so easy to deploy. Anywhere, Heroku died, True. So render IO, fly IO. So like that's the easiest solution you have. It's one command you deploy it. The only reason. Sorry?
No, but I mean, I don't use Kubernetes because I spend all my time managing a cluster instead of clearing value to the customer.
Exactly. As a startup, the only thing you care about is like, how can I get more customers? So you don't really need Kubernetes. Once you get some customers, then you can actually say, okay, now I can use some Kubernetes. So basically what you need is like literally a server, a Docker compose inside, and you're good to go. You don't need anything extra. You have some microservices, okay, sure, we'll throw in Docker Swarm, do some scaling. Again, one server. Mesos and Nomad, yeah, I think the only good example for Mesos was Netflix, but they literally rebuilt the whole thing. And Nomad is still getting used, but that's by Ali Cloud, not so much here in Europe. ECS and Cloud Run are the easiest ones. There are alternatives. Again, configuration-wise, it's a lot easier than Kubernetes. Right, Cloud Run, again, you just get the VM. Cheers. So when would you scale? On which stage? So let's say again, you have a startup again, you got yourself customers, when would you scale? What would be the best time for scale?
I think it depends on the need of each application and is it a front-end application? Probably render. It just needs a CDN and good luck, have fun. Like that's it.
Yeah.
Your bills come in. I mean, if it makes sense, you move it. If not, you just.
Okay.
keep
Then
it
I'll
there.
change the question. What kind of application would you require in order to use Kubernetes?
I would say I would go towards Kubernetes or just something different than different vendors when you need to align various processes within your company, like to streamline the way you do certain things. So now you have a product, it's proven that it works, and you need to scale it up.
Exactly.
That's when you would try to streamline processes. Thus, you would have to introduce like a different way of working.
Correct. So, magic keyword, when I have customers. When I have customers and then there is a huge need for me to scale.
I would say when you have traffic. Customers and traffic are not always the same thing.
It depends on your product, I'll give you that. Yes, so if you have some kind of a tool that, I don't know, collects metrics, for example, and you expect huge amount of metrics, yeah.
Not necessarily, but for example, for us, it's like customers versus robots, it's at least 10 times the amount is robots.
Yeah, okay.
So, it depends.
Okay, yeah, but that's
You can have more traffic than customers.
true. That's a edge case, but true. So yeah. Yeah. So as we said exactly, now project complexity, resource constraints, cloud provider preferences, the learning curve, operation overhead, and scalability requirements are the 6 that I personally identify as the main topics basically of me choosing Kubernetes or not.
Alex, why don't you just have personal preference? Because the places I've been that run Kubernetes is because someone or some architect used it or wants to use it. And they never do this.
True, but I would say that the architect, at least, you speaking like as an architect, by the way, at least have common sense.
No, but I'm just saying most places I've been,
Yeah.
and I think I've been 7 or 8 places where they were chose or not chose, and it always boils down to someone says, I used this before and I think it's really neat, and they don't look at like, should we use another managed service instead, or use ECS or use something in Asia or refactored application. It's always like, yeah, we did this or not.
I agree with you totally. I had also a case where it was an event-based system and they were like, okay, we should go Kubernetes. I was like, why? You can also go Lambda. It's a lot easier with Lambdas. But it's the hype that wins the war. It's not really the need. But yeah, I know it was a boring presentation. Thank you all for listening. I'll take those claps. I think I deserve them. Sure. So, yeah. Any questions? I think we made this interactive enough. But if anyone has anything else to ask,
So why did you decide to go to Kubernetes?
I told you Pokemon Go, dude. Pokemon Go. That's it. It won. At the moment that Kubernetes won, we got like Pokemon Go. Sorry, survived. We got Kubernetes.
At your company right now running Kubernetes?
Hell no. Like at my customer, we're running Kubernetes. Yeah, at my own company, no, I'm not running Kubernetes. I'm running Render, I'm running Versal, I'm running whatever I find, except Kubernetes. I don't want to manage them.